Now let us see the centroid of some plane figures. As we have understood from the definition of centroid, that centroid is that single point over which the entire area is acting. Now I will be giving the centroid for different plane figures, because centroid is applicable only for plane figure, or it is called as lamina. It is not applicable for solids. So here I would be giving centroid of some plane figures. Let us start with the first lamina, or we can say plane figure. The first one is rectangle. Now if we have a rectangle whose width is b and height is d, for a rectangle centroid is located at the intersection of the diagonals. So if we want to calculate what are the coordinates for this centroid, coordinates are given by x bar and y bar, where x bar is the distance with respect to y axis and y bar is the distance with respect to x axis. So x bar for a rectangle, it is, if the width is b, x bar is half of b, so it is b by 2. Y bar, it is the distance of centroid with respect to x axis. Height is d, so y bar is half of that, so y bar is d by 2. So in order to find, if we want to find the centroid for a rectangle, it will be denoted by x bar and y bar, where x bar is half of width, y bar is half of height. So that was for a rectangle. Next, if we have a triangle. Now here I am considering a right angle triangle. This is applicable to any other triangle also. If we are having a triangle which is kept at the origin, triangle is having base b, its height is h. So centroid is located at distance of x bar and y bar, where x bar is with respect to y, y bar is with respect to x axis. So now x bar distance, it will be b by 3, because if we are measuring it with respect to the base, it is b by 3 from base, and y bar will be h by 3. So for a triangle, centroid is located at x bar, which is equal to b by 3, that is 1/3 of base, and y bar, that is 1/3 of height. So if we know x bar, y bar for a triangle, we can locate the centroid. The next figure is a circle. Here I am considering a circle having radius capital R. Centroid for the circle will be at the center, and if we are keeping this circle at the origin, in that case x bar and y bar, both the values would be same and they would be equal to the radius of the circle. So this is the location of centroid for a circle. If we have semicircle and it is placed in such a way as shown in the figure here, then the centroid would be located by x bar with respect to y axis, y bar with respect to x axis, where x bar value is equal to the radius of the semicircle and y bar value is 4r upon 3 pi. Remember, this 4r upon 3 pi value is with respect to the diameter of the semicircle. We have to be careful, because if the position is changed, then the y bar value will change. In the last, we have quarter circle. In quarter circle, the centroid is located by x bar and y bar, and this semicircle is, this quarter circle, it is symmetric about an axis which is called as AOS, axis of symmetry. So for a quarter circle, the axis of symmetry is at 45 degree, and x bar, y bar values both are same, they are 4r upon 3 pi. So in this way we would be locating the centroid for a quarter circle. So in this video we have seen how to locate the centroid for some of the plane figures.